Hi, thanks for joining us. In this video, we'll dive deeper into Timbr's virtual schemas and how we can leverage them for different scenarios and use cases. In case you haven't seen the first video of the SQL Editor where we cover the basic functionalities, I recommend watching it before continuing with this video. You can find the video in the Academy playlist on the Timbr YouTube channel. Great. So in the SQL Editor, we'll begin by choosing the knowledge graph we intend to query, as well as the data source. If we are interested in querying multiple data sources at once, then we'll simply choose Timbr virtualization as the data source. Please note that it is mandatory to choose a knowledge graph and data source in order to successfully perform our queries. Once we've chosen the desired knowledge graph and data source, we'll choose the schema as well as the table or concept we wish to query. Unlike the knowledge graph and data sources that are mandatory to select, the schema and table are optional. The main reason to select the schema and table is to view the metadata of the tables or concepts, making it easy and convenient to build our queries. When opening the Schema tab, we will see both the physical schemas of the database as well as the virtual Timbr schemas that come built into each knowledge graph, which we will view and discuss shortly. Once the schema is chosen, we can choose a table or choose a concept depending on the schema. If it's a physical schema from our database, then we'll see the tables. If it's a virtual schema of the knowledge graph, we'll see all the concepts defined in the knowledge graph. Once chosen, we will get the metadata of the table or concepts that can be easily copied and used to form a query. Now, let's dive into Timbr's virtual schemas that expose the knowledge graph concepts. First, we have the schema called Timbr, which offers two things. The first is to query all the knowledge graph system tables which contain all the information regarding the chosen knowledge graph. So for example, after selecting the Timbr schema, we can choose to query the system ontology table. Once we run the query, we will see all the information about the ontology model, which includes the concept names, the concept's inheritance level, who they inherit from, the concept description, and more. The second thing we get using the Timbr schema is the ability to view and query concepts as tables and properties as columns. So if we scroll down beneath the system tables, we can find all the concepts in the knowledge graph and choose any concepts we'd like and view their properties. This makes using the knowledge graph a simple activity for anyone that already queries tables in a database. So we see the concepts and their properties, but how can we leverage the graph relationships between different concepts at the same time? For that, we will jump to our second schema, which is called dtimbr. The dtimbr schema, also known as the denormalized schema, exposes the concepts with their relationships to facilitate data integration. Let's see an example. Now, when choosing a concept, we not only get its properties, but we also get its relationships that connect to other concepts in the knowledge graph. So if before using Timbr, when looking at the customer table alongside the orders table and having to figure out how to join the information from both, now, with dtimbr selected, we can simply access the customer's relationship with the other concepts and traverse through the graph using that relationship. So when we copy a property through a relationship and paste it in our query box, we can see the syntax, which begins with the relationship name we defined in the knowledge graph. Then, in the parentheses, we see the target concept we're accessing, and finally, we see the property we would like to fetch. But this can be taken a step further. We are not limited in making one jump through our data, meaning we are not limited to query only concepts that have a direct relationship. We can also traverse and jump through the relationships and join information through multiple relationships even when the concepts don't have a direct relationship between them, doing so by leveraging a concept they're both related to. We can continue to use the relationships and travel across concepts. For example, we can perform another hop on the graph, starting from the customer concept, going through to the order concept, and using the order relationships to hop once more to the product concept. This process can repeat itself many times, enabling us to travel through the knowledge graph, creating queries with ease that require no joins and no unions. When querying, we can also use our knowledge graph model to help us optimize our queries using business logic. So for example, in this query, when we are querying all the customer data and its relationships to other concepts, we might be interested only in information regarding specific types of customers, like corporate customers. This would usually require users to add a filter using a where statement. In Timbr, since it was already modeled for the business use with customer classifications, it is as simple as changing the concept name from customer to corporate customer, giving us information only about our corporate customers. So we covered Timbr and dtimbr. Our next schema is the vtimbr schema, which exposes the views we create in the platform. There are a couple of options to create views in Timbr. It's worth noting that we can simply form a query just like the one we formed here and click on Save in order to save the query as a new view. Let's jump over to the Ontology views and see how users can create and edit their views. We'll click on the Model tab and choose Ontology views. Next, we'll choose our knowledge graph we're working with. Great! We now see the different views that exist in our knowledge graph, and we can copy them, edit them, or create new views if we'd like. For now though, let's look at the 3 different types of views that can be created in Timbr, which we discussed earlier. The first option is to create a view on top of the physical tables in the database, which is the standard views that users create today. This view counts the number of orders and adds the delivery status and shipping mode, and we can see it's querying the physical schema and table. This option enables users not only to create the views, but also to import existing views into Timbr for easier access and control management. Users can also click on the lineage to see what are the dependencies for this view and get the full lineage down to the source. The second option for creating views is the creation of views on top of the knowledge graph concepts, enabling users to combine aggregations using the knowledge graph relationships and facilitate the query required to build the view. Here, we created a view to calculate the order profit per product and customer segment. We can see that this view is querying the virtual schema dtimbr using the knowledge graph concept customer. One may ask, why not just create the view from the physical table like we showed in the previous example, instead of creating the view from the knowledge graph concepts? To answer that, we can simply click on the Explain Query button and see exactly what query we would need to write if we were querying the physical data source without the use of the knowledge graph. A significantly longer query with multiple joins and logical rules. The third and final option is the creation of views using existing views, which enables users to combine aggregations using the knowledge graph relationships. Here, we created a view to add profit aggregations leveraging the vtimbr schema and the view we just saw in our previous example, the view on top of the knowledge graph concept. Once more, we can click on Explain Query and see the query we would need to write without Timbr. A much longer query that also contains multiple joins, aggregations, and logical rules. When creating a view on top of a view, the lineage feature becomes crucial in understanding the dependencies, as you can see here, where we have our first view querying our previous view, which is built from these concepts, which are mapped to these tables, coming from this data source. Regardless of the type of view, whether it be a view from the physical data, the knowledge graph concepts, or perhaps a view on top of a view, all views will appear as virtual tables to our users. Let's quickly head back to the SQL Editor and see what this would look like to our users. We'll open the vtimbr schema and choose one of the views we just covered. We can see the metadata is just like any other table or concept, and when querying, we just need to use the vtimbr schema like in this query. Well, there you have it. We got to discuss how to form our queries by choosing the knowledge graph, data sources, different schemas, along with their features. We also had the chance to review the vtimbr schema for creating different types of views and querying them. In our next videos, we will discuss 2 more schemas that we didn't touch in this video. The etimbr schema, which is an exhaustive schema of the knowledge graph concepts, and the gtimbr schema, which is the schema that exposes graph algorithms to run in standard SQL. I hope you enjoyed this video. We'll see you in the next one. Thanks for watching and have a great day.